Let's continue on with 11.2, section part B. Here we are in example 3, last example. Simplifying expressions and solving equations with combinations. In A, we're asked to express as factorials and simplify. N choose 5 divided by n minus 1, choose 3. So what we're going to do first of all is look at the top. N choose 5 means it's n factorial over n minus 5 factorial times 5 factorial. On the bottom, we've got n minus 1 choose 3, which means that we're going to have n minus 1 factorial on the top and n minus 1 minus 3, which is n minus 4 factorial, times 3 factorial on the bottom. Now, we're going to invert and multiply. To do that, we're just going to rewrite this as a multiplication, just like fractions, multiply by the reciprocal. Now we're going to change things a little bit. We're going to write n factorial as n times n minus 1 factorial. Then on the bottom, that won't change. On the top, on the other side, this is going to be written as n minus 4 times n minus 5 factorial times 3 factorial, of course, over the bottom, which is n minus 1 factorial. That we're not going to change. So we just changed two things there. But now this is going to allow us to cancel some of these terms out. So if you'll notice, I can cancel n minus 5 factorial with the other n minus 5 factorial because I'm multiplying now. I can cancel the n minus 1 factorial with the n minus 1 factorial. Now notice I've got 3 factorial on the top and I've got a 5 factorial on the bottom. Well, I'm going to rewrite that 5 factorial as 5 times 4 times 3 factorial. Now I can cancel the 3 factorials. This leaves me now, I can go ahead and multiply it out. There's nothing else I can cancel. On the top, I'm going to get n times n minus 4. And on the bottom, I'm going to get 5 times 4, which is 20. Final answer. Part B. Solve for n. We're going to solve an equation now where we have 2 times n choose 2 equals n plus 1 choose 3. All right. Well, just write that out first of all. Now we're going to write it as factorials. We're going to have 2 times n factorial over n minus 2 factorial times 2 factorial, and that's going to equal n minus 1 factorial over n plus 1 minus 3, which is n minus 2 factorial, times 3 factorial. So, we can go ahead and do some canceling now. What we can say is the 2 factorial on the bottom is simply 2 times 1, or just 2. So that 2 will cancel with the 2 out in front. So those 2 can cancel. Next, I have an n minus 2 factorial on the bottom on one side, and I have an n minus 2 factorial on the bottom on the other side. So if you just imagine multiplying both sides by n minus 2, those 2 are going to cancel, or n minus 2 factorial. Now I'm left with n factorial is equal to n plus 1 factorial over 3 factorial. If I put that over 1, cross multiply, and then divide, rearrange things, I've got n factorial on the bottom, n plus 1 factorial on the top, and 3 factorial on the other side. So now I'm going to rewrite n plus 1 factorial. So we'll say 3 factorial is n plus 1 times n factorial. I still have n factorial on the bottom, which means now I can cancel those 2. Now I'm left with 3 factorial, which is 3 times 2 times 1, which is 6, is equal to n plus 1. Subtracting 1 from both sides leaves me with n is equal to 5. My final answer. So, Here's our key ideas or summary of 11.2. A selection of objects in which the order is not important is called a combination. When determining the number of possibilities in a situation, if order matters, it is a permutation. If order does not matter, it's a combination. That's the difference between the two. And the number of combinations of n objects, taken r at a time, can be represented by n choose r. N, of course, has to be greater than or equal to r. You can't take more items from less items. And r has to be greater than or equal to 0. You can't take negative items away. And that means that it's going to be written as the final form of n choose r is n factorial over n minus r factorial times r factorial. Your assignment for this section is to do page 534, numbers 1 to 18.